Hello and welcome to the last lesson of Chapter 1, Lesson 5. Maybe you recognized one of our former professors here. We can't go on like this. Well, what am I talking about? Well, if we think about the ideas that we've had so far in this chapter, we've had some undefined terms. Can you name a few? Terms that we just use without really any explanation, any definition. Point, line, plane, and there are others. We've guessed at some conclusions like the four-color map problem using what kind of reasoning? Was it deductive or inductive? The fact that we're guessing makes it inductive reasoning. We're using some examples and making a guess. We've done some constructions like, well, there were two. We bisected a segment and we bisected an angle. But in so doing, we just followed some steps that we didn't really understand. And we can't actually be sure those constructions work yet. That'll come. So really, we don't have explanations why any of these things work yet. And that's what we mean. We can't go on like that. It's all been kind of trial and error, and we need something that makes us a little bit more positive. One example from history we're going to look at of trial and error and not always working out. Figure out what this is yet? Fields in Egypt. Egypt, of course, along the Nile River, it flooded a lot and fields were washed over, so they did a lot of surveying. They were good at that. But then they also charged taxes. You remember during Joseph's time, he had taxes on each of the people, probably before that. How would they charge? Well, they would charge taxes on the land based on the size. See a lot of shapes there. What would you call those shapes? Hopefully the word polygon came to mind. Most of them appear to be polygons. Maybe this one up here, maybe not so much. It's got the little curve in it, and this one next to it. Most of them are polygons. So the Egyptians came up with a method through trial and error to find the area of fields shaped like quadrilaterals. Did you see that most of those look like quadrilaterals? Maybe there's a pentagon over here. So what was their process? This is the equation they came up with. The area of a quadrilateral is 1/4 of the expression A plus C times the expression B plus D, where A and C are opposite sides of the quadrilateral and B and D are opposite sides of the quadrilateral. So let's take a quick look at this then. So they would look at this parcel of land and say, well, there's A and C. Let's add those two together. And there are two opposite sides, and we'll add those two together. We'll multiply them right next to each other like that. Multiply. And then we'll take 1/4 of that. Keep in mind, sometimes it's easier to do it in your head if you add 2 and then just take 1/4 of one of those sums. That'll make it a little bit easier to do in your head sometimes. You might see that coming from. So does this work on a square? Well, let's plug in the equation here. Since it's a square, we know we've got 4's all the way around. So be 1/4 of 4 plus 4 times 4 plus 4. 1/4 of 8 times 8. 1/4 of 64. That's 16 square units. Watch the label. And if you look at our square over here, we know the area of a square is side times side, or side squared. 16. Yeah, it works. Perfect. Does it work on a rectangle? Well, from the other day, earlier in this chapter, we know that the area of a rectangle is length times width. So this one should come out to 12. Does it work with the Egyptian process? Try to work that one through in your head before I show you here. 1/4 of a plus c. It doesn't matter if you start with these as a plus c or those as a plus c. 1/4 of, did you pause it to try to figure it out first? 1/4 of 3 plus 3 times 4 plus 4. 1/4 of 48 is 12. Yes, it works. Perfect. So we're using an example of inductive reasoning. We've tried a couple patterns. They seem like they work. So we think we have a way to find the area of any quadrilateral. And the Egyptians thought that, or at least the taxmen wanted everybody to believe it worked. That may lead you to suspect something isn't quite right. So here are 3 plots of land from ancient Egypt: Ramses, Cheops, and Ptahhotep. So using the quadrilateral formula the Egyptians had, let's try to calculate these 3 areas. Can we do it in our head? Ramses, 10 plus 10, 20. 10 plus 10, 20. 20 times 20 is 400. Take a fourth, 100. There was an example where I could have taken 1/4 of 20 first and got 5, and then multiplied by 20. But you could do it in your head. Okay, try those other 2 for yourself. Maybe pause it, see if you come up with the same as I do. If you're back, 11 plus 11, that's 22, plus 16. Let's take 1/4 of 16 right away. That's going to make it easier. That's 4. So 4 times 22, 88 for Cheops. Ptahhotep down here. Let's see, we've got 14 and we have 28. Well, 1/4 of 28 is 7. 7 times 14 comes out to 98. So according to the results, who has to pay the highest tax? And it seems pretty clear that it would be Ramses with 100 square units. Well, let's see if this actually works out. This one looks like it belongs to Cheops. And that one's pretty straightforward. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8. 11 times 8, 88. So that one's right on the button. This next one, I think this was Ramses. We're going to take kind of an interesting approach here. We're going to chop off this left side, move it over here, and you'll see it makes a perfect rectangle, which now is a little bit easier. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 10 times 8 is 80. Do you remember what he had before? Let's back up. Ramses, they calculated him at 100, and his is really only 80. Inductive reasoning didn't work out so well here. Here's the last one, Ptahhotep. Can you see the strategy here? The yellow is the shape of his land. So we've drawn a line from that vertex down to that one. Duplicated the triangles to make rectangles, 2 rectangles. We can find the area of this first one. 1, 2, 3, 4, 5 times 2, 4, 6, 8, 10, 12. 5 times 12 is 60, but it's only half of that. So we've got 30 over here on this side, 30, so I don't forget. Over here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times, what was it going down? 2, 4, 6, 8, 10, 12. 9 times 12. But then we're going to have to take 8 or half right away. 9 times 12 times a half. Let's take half of 12 first. That's 6. So 6 times 9, we can do that in our head. We've got 54. So the total here is what? 84? What did the Egyptian equation come up with? I have to take a quick back up and see. 98. So in two of those cases, the approach that the Egyptians used, that inductive approach, gave them some wrong answers. So which one of the three is cheated the most by the tax assessor's formula, and why? Well, clearly the Egyptian formula didn't work. It gave too high of a value. So how to calculate area correctly is an important topic in geometry. Having worked through these exercises, you'll probably agree that it would be convenient to have easier methods whose logics we really understood. And that's why we said we can't go on like this. If you would like to take a shot at, this is the only thing that's going to be assigned from this particular lesson, set 3. It's a really good example of inductive reasoning and how it doesn't always work out quite the way it should. So it takes a little bit of work here, but it's kind of interesting. The idea is you draw a circle and put a certain number of points on, maybe 2, maybe 3, maybe 4, and see if you can discover a pattern. See if you could look at any circle and say, hey, if you put 5 points, you're going to end up with, well, in this case, we're looking for how many regions. How many regions would the circle be separated in? So they walk you through step by step here, and here they're suggesting, and this is always a good suggestion, to make a table. If I have 2 points, there are this many regions. 3 points, this many regions, and so on. And as you work down through number 10, we'll see what you come up with. So that's the end of this. Check well, there is no assignment on this lesson. This was just a lesson to get you ready for the rest of our book so that we don't settle for things that we are not absolutely sure about. We're going to use deductive reasoning. We're going to use logic to come up with things that we know have to be true. All right then, hopefully you take a shot at that set 3. That's a